Hey, what's up? This is Doug with Design 8 Studio. I'm a big fan of V1 engineering and the free open source plans that Ryan makes available for awesome machines. One of which is the mostly printed CNC and also its big brother derivative, the LowRider, currently in its third version. I've built two of the LowRiders. Actually, I built a version 2, then upgraded it to a version 3, and then built another version 3. Ryan has an excellent design combo for the LowRider version 3 that is a router mount for the Makita 700 series router plus a dust shoe. And that dust shoe works great for dust collection, except when your LowRider is riding high above the material where the gap is too great for successful dust collection. And since cutting and pocketing deeply on thick materials requires a longer bit, and that cut usually has to start with the tip of that longer bit barely into the material, it means that for at least part of the cut job, the LowRider is going to be riding high, and at that point it's going to be spreading sawdust or chips. It's been a desire of LowRider makers to have a way for the dust shoe to stay close to the material for the whole job. Now, part of the strength of the LowRider design is that the closer it gets to the material, the more rigid and stronger the CNC machine is. This is the exact opposite of how most CNCs work. And it's one reason why it's been worth it to put up with any issues in dust collection, because of that added rigidity as you get closer to the material. But this is accomplished by having the whole X gantry to rise and fall in the Z-axis on a LowRider. Not just the router itself or the core rising and descending, but the whole X gantry. And so most dust shoe approaches of the CNC world are non-starters. Most CNC designs have a gantry that doesn't travel up and down in the Z-axis. And so this has been discussed at length on the V1 Engineering Forum. One workaround has been to remix and print slide-on shoes, dust shoes that have higher height. They're thicker. They get closer down to the material, and then pause the job and swap out the tall dust shoe for a shorter one as the core moves down closer to get deeper into the cuts. This means that every time you want to swap a taller dust shoe for a shorter one, you have to temporarily pause the job, turn off the router, then swap the dust shoe, then turn the router back on, then start the job again. So it's doable, it's not real convenient, and so it's less than ideal. So there are at least two basic approaches to tackling this. One is to create a secondary gantry that's attached to the LowRider's YZ plates on either side, and this secondary gantry does not rise in the Z-axis. And then attach to that secondary gantry a height adjustable dust collection system, which can be set and stay at the same Z height for the whole job. There's an engineering challenge here in that this dust collection rig needs to stay in sync with the LowRider core in the X-axis as it moves back and forth, but not in the Z-axis as the core and the gantry itself move up and down. Now, there's an ongoing effort of that approach by Chris, who goes by Fodder1 on the V1 Engineering Forum. His effort is currently underway, and he's kind of tackling one direction while I'm tackling the other. The other option is to create a floating Z approach that attaches to the existing LowRider 3 core, and it can adjust on the fly as needed to stay close to the material. The basic idea here is that you would unleash it from some type of a restraint or latch system, and when you're ready to start the job and you've already got everything zeroed in, you would unlatch it and let it drop down onto the top of the material. It would have brush bristles of some type. My first effort is going to try with bristles made of EVA craft foam. And if that doesn't work out, then I'll switch to some printed TPU brush bristles. But in my efforts to tackle this other approach, I have made a beta test version of my design available on my printables.com account, and I'll put a link in the description for that. This is definitely a work in progress as of the posting of this video. Currently, I've printed all the parts. I'm using PLA for printing all of those parts. And I'm already in possession of some craft foam. It comes in 12-inch by 18-inch sheets. They're about 2.3 or 2.4 millimeters thick. And I used my CO2 laser to cut out bristles out of that craft foam. And so far, they're working really good. I'm also waiting on the arrival of a couple of recently ordered items that I'll need. Some 2.5-inch flex hose. I'm only going to need 115 millimeters of that for this project. And some 2.5-inch key hose clamps. I'll need 2 of them to attach that 115 millimeters of flex hose between the upper part of this floating Z system and the lower part that moves up and down. The concept here is actually the reverse of that. The flex hose will go at the bottom to the dust collection system that is kind of sledding or skating on the material and not changing its Z height. The top of that bit of flex hose will be attached to the LowRider core, and as the LowRider core lowers or rises, the flex hose would be able to compress or expand as needed to keep the suction across that changing distance. So if you are a V1 engineering maker, a fellow LowRider maker, and you'd like to help test this approach, and you don't mind being a little adventurous and having a potential possible loss of a little bit of wasted PLA, please feel free to print this out and assemble it and try it out. Regarding the bristles, there are at least 3 ways to accomplish this. One is the EVA craft foam. I mentioned the printed TPU bristles. And lastly is buying an actual dust shoe brush. And you can buy these on Amazon and other places. And I've bought some of that, but it's too thick to fit into the groove on the bottom of my dust shoe here. And so I'm not going to go with that approach. And there is the possibility of actually cutting the bristles loose from the brush strip that's too thick and then just epoxy gluing loose bristles into the groove. And I'm also not interested in doing that kind of approach. I've already done the laser cutting, and it really came out wonderfully, cutting the craft foam to get the bristles. So if you have some craft foam on hand and it's a large enough sheet and you've got a laser cutter, you're set. You could also just cut a 24 millimeter strip and cut it to the proper length, which I think is somewhere around 317 millimeters to 322 millimeters in length. You can then insert that. My thought is to glue that strip of craft foam in, possibly with some rubber cement. And then you could just actually use scissors to just snip your slits into it to produce your separate bristles. And in my listing on printables, I've provided a 2-dimensional graphic that can be brought into Lightburn to do the laser cutting of the bristles. And I've also made a couple of STL designs available. One is a single piece for printing all of the bristles in case you have a really large printer like an Ender Extender 400 XL. And then another option that has half the bristles on a left side, and then another half of the bristles in a separate print on a right side. So those designs could fit on normal 3D printers. It's possible that the linear guide and the slide bearing truck could be of the MGN 9 size instead of MGN 12. But I went with the MGN 12 for both familiarity's sake, because all LowRider makers have already used MGN 12 in making their LowRider, and also because it's got a little bit more resistance to deflection than its smaller, thinner MGN 9 junior brother. and the cost difference between the two is negligible. I'll put links in the description to all of the items that I have ordered for this. And if you click through into the printables post for this, you'll see lots of illustrations and images that will help you to get a grip on how this is supposed to look. One of the things that I kept in mind is the possible need of being able to temporarily clip the floating Z rig at its maximum height to keep it out of the way while working on bit changes. One option for that I really like is to just 3D print a plastic bar, glue some magnets into it, and if it will stick to the slide bearing, it could just rest there when it's not needed, and then when it is needed, you could just pop it off of the slide bearing and attach it to the linear guide below the slide bearing, and it would work kind of like just putting a board in an open window to prop the window open. This 3D printed plastic bar would just prop the floating Z-rig up in its top position. The possibility of having to keep up with that separate printed bar with the magnets in it and the possibility of losing it caused me to explore other options. One that I came up with, and I don't know if it's going to work, is to have a slide latch. So I worked up a design in which I have an alternate B version, a B option, the linear rail mount that has a little protrusion on the side where a hinge pin can go. My plan is to use an M5 bolt for that hinge pin. And then I designed a latch, and the latch would be spring loaded, and the idea is to use the spring taken from a common writing pen. And again, the illustrations for this make it clear if you want to try that. I wanted to mention also the question that has come up in discussions about this on the V1 Engineering Forum, which is that if we're able to succeed with a dust shoe that stays close to the material and has bristles that are helping to constrict the airflow so that the suction is able to actually pull the sawdust and chips out, then do we want to change how much constriction there is on the bottom of the dust shoe? And so, not being someone who is fluent in the engineering of fluid dynamics, I'm not really sure on which way will actually be the best. So I've mocked up one that is what I call quarter open, one that is half open, and one that I'm calling full open. And I'm actually just going to do some testing I'll print all three of them and just do some testing and come back with a report on which one seems to work the best. I've already got the quarter open one printed, and I've already got the EVA craft foam bristles cut for it. And I'm only just waiting on those items that I ordered from Amazon to arrive so I can actually put together a functioning floating Z dust collection system on my LowRider V3. I invite you again, if you're a fellow V1 engineering maker, to please be willing to test this if you use a Makita router and if you use a 2.5-inch dust collection hose. Please feel free to print out the parts and assemble this and test it on your setup and give me feedback on how it's working or how it could be improved. Let me show you some video of the actual laser cutting of the foam and the actual assembly of it, and then that will conclude part one of this little adventure. And then as soon as we have more progress to show you, we'll be back with a continuation. And I'm about to use light burn with my 100 watt CO2 laser to cut some EVA craft foam into a shape intended to serve as bristles for a dust shoe for my LowRider DIY CNC. I've never cut this kind of thin EVA craft foam before, but my research indicates you want to have low power so you're not pumping a lot of heat into the foam. So I'm trying a speed of 20 with a power of 25, and I'll check it to see if it's actually successfully cut through, and if not, I'll adjust and rerun the job. So the first thing we need to do, by the way, I've already used my height checker to make sure my focal length is right on the distance between the tip of the laser nozzle and the foam. So I'll go ahead and frame the job. All right, the job appears to be positioned properly. So now we will go ahead and start. From what I can tell so far, it looks like I had my settings about right. I think that it's cut completely through, but what I don't understand is why my bristles didn't cut. Okay, there we go. Bottom of the bristles are being cut now. It definitely seems to be cutting all the way through. In fact, if anything, I may have put too much power on it, even though I was trying to put not too much. All right, she is done. Let's see how it came out. I gotta feel good about that. First time cut EVA craft foam with my laser, and I feel like it came out very good. Let's go see how it fits in the dust chute. Okay. So we just got done printing our bristles out of EVA craft foam. I do have a little bit of smoke on this, but that part's going to be facing inside. I've got a little bit of stain on here, probably from some PVC primer. Not sure when that would have dropped onto it, but I'm okay with that. So this is the part. Let me snip this out. This is the part that it fits into, and you'll see the end has a little extension, and that's made to kind of cover this little distance right here. I think when I'm finally ready to do this for good, I'll use a little bit of glue, probably some rubber cement. To hold that in place. You can see those little extensions right there. Looks like I could have afforded to make them slightly longer than I did, or maybe the curve of the laser took off a little bit, but I'm real happy with that. So with my floating Z, that would rest on the material. And if it had to get pressed down, it could afford to be compressed down. And if it needed to hop over a profile part that was jutting up, I would have a little bit of leeway for forgiveness on that. So I may cut it again, maybe a color matching. I've got a red, I could cut it with a piece of red foam, but I'm real happy. Real happy with that. All right, that's about it for part one. Please click like and consider subscribing. And until the next video, I wish you happy making.